let's go to the problem of the day. First off, folks, here we go. A right triangle has legs of 16 and 12 inches. Find the measure of its hypotenuse, perimeter, and area. So a right triangle has legs of 16 and 12 inches. Find the measure of its hypotenuse, perimeter, and area. Let's take a look at this one and see what we've got going on. First of all, if you'll notice, we've got a figure ready to go. Now, it's a right triangle. This doesn't work unless we have a right triangle. So here we go. Box it in right there, and now we make it a little more official. All right. Now, legs, hypotenuse, perimeter, area, all these are important words. All these are important words. So let's go make sure we got them down. The legs, first of all, form the right angle. All right, they form the right angle. So my legs here are 12 and 16. I'm going to use my eyesight. I'm going to say this one is going to get the 12, and this one is going to get the 16, all right? We're in inches, all right? So we're going to keep things either in inches or square inches as appropriate here, all right? So it says, take and find the measure of the hypotenuse. Now, the hypotenuse is the longest side of a right triangle. By the way, they only work in right triangles. We don't have them in acute triangles and such. So we'll call that for right now, like we'd like to say that a squared plus b squared equals c squared. We're going to call that c, okay? It's hypotenuse. Now, perimeter, that means we've got to add all three sides together. Well, you're halfway. No, you're 2/3 of the way there. You got 2 out of 3, all right? Got to be precise on Mathline. And then the area, we'll use a formula and get out on that, all right? So let's take one thing at a time. By the way, you could find the area without knowing the hypotenuse, all right? You can do that. Yes, you can. Yes, you can. Yes, you can. It's a right triangle. That's the way it works. So let's play with this thing. Let's play with this thing. Mention Pythagorean Theorem, all right? That's where we're going to go because it is a right triangle, and the Pythagorean Theorem says if we square the legs and we add those results together, it equals the square of the hypotenuse. So I'm going to go to that infamous formula we love to call it a squared plus b squared equaling to c squared, all right? There you go. That's our start. That's our starting point. Now, what do we know? What do we know? We know 2 of the 3 pieces here. So let's put them in there. We got a 12 going right here. We have a 16 going right here. And you know what we're going to do? We got to square these. So put a little squaring on those, and we'll add them together just like the formula says. So 12 squared plus 16 squared equals, the hypotenuse squared, c squared. Now, do you know your perfect squares? It really helps if you do. Let's see. 12 times 12, where are we going with that? That's going to give us 144, all right? The 16 squared, we'll kick that one around, 256. 256, nice to know these, at least up through 20 squared, equals, c squared. We don't know what c is, so we just leave it there. But what we are going to do, we're going to add 144 and 256 together. It's going to pop out 400, right there it is. And that's what c squared equals. Now friends, be careful here. That's not the length of c. It's not 400 inches. 400 is what c squared. So we're going to have to square root that c squared to get back to c. That's how we undo a squaring. Let's do a square root also on 400 there. And that's nice. This is another reason why I said let's know your perfect squares, at least up through 20, because that's what c equals, is 20. That's the square root of 400. So right there we go, square root of 400, that gives us 20. So there is our hypotenuse. Now, we are 1/3 of the way there, right? Because we have done the hypotenuse. I love the way I can incorporate some fractions in on a geometry problem, even there weren't any in the original problem, are there? We're 1/3 of the way there. Let's get to the second third. The second third is real easy. It's very easy. In fact, the other 2 pieces are really easy. Perimeter, just simply add all 3 sides together. Let's see if we can add those up together and do them correctly. So perimeter is equal to 12 plus your 16 and tack on the 20. All right, it's 12 plus 16 plus 20, which is going to give me 48. Now, let's go back just a second because I got a little moving fast here. This is inches, all right, 20 inches. The perimeter is 48 inches, all right? You say, well, Ernie, what's the area? The area, let's look at it. Area equals 1/2 the base times the height, all right? 1/2 base times height. And you say, well, what is that? Is that A and B? Yes, it is, because the base and height form a right angle together, all right? That's where it kicks. So let's look at it. We've got area equaling 1/2 of, how about it? Base, 16. Height, 12. Let's put it on in there. And we're good to go. Let's take half of 16, might as well. That gives us 8 times 12, and that gives us, looks like, how about it, folks? What do you think? Is it going to be 96? 96 sound good to everybody? I like it. 96. But what are the measurement on it now? It's 96 square inches because we are dealing with area, okay? So 3 pieces. Hey, 3/3, problem is done completely. Again, the side, the hypotenuse, gets 20. Add it in with your 2 legs, you're at 48. And then run through the area formula. You didn't need to know the hypotenuse for the area formula, but it's simply 1/2 base times height. Remember, base height connect to make perpendicular right angles. That's what you're looking for. Where's the right angle in this thing? Right there it is. And run it through the formula, 96 square inches. So there you go, problem of the day. How about that?